So today guys, we'll be doing probability. Be greeted. Please do not forget to subscribe and like. So probability is actually the chance or the likelihood of something occurring, the 50% chance that something will happen or that something will never happen. Hope that makes sense. So under probability, there's something that you must know known as a sample space. So a sample space is actually the total number of participants that are actually participating in a survey, if I can put it like that, the total number of people who are participating in a survey or sport or whatever. Then we have something known as the favorable outcome, the chosen result, or the favorable result. Now, for an example, let's say we know that the sample space is the total number of people participating in a survey or whatever it is. Then the favorable outcome is the chosen or the favorable outcome, the outcome that was actually, or the outcome that is actually chosen, or I don't know what to say, but you understand this. Now, a probability is actually the favorable outcome over sample space. You having the sample space doesn't mean that you have probability, but probability is the favorable outcome divided by the total number of people participating in a survey. That's it. That is sample space. I hope that makes sense. So probability is actually a favorable outcome over the sample space. Then the answer that you're going to get, it will be probability, the likelihood of something occurring. So let's say we have the percentage mark that we have is 100%, and maybe a learner obtains, for an example, let's say the exam percentage you got, okay, the exam percentage is what is 75. This is the one that you obtained, right? Then the 75 now over the sample space becomes the probability. Okay, let me just use this example. Now the total mark of a maths test, the total mark of a maths test is 100, right? This is what the sample space. Then the mark obtained, the mark that you obtained, the mark that you obtained is 85. Therefore 85 over 100, the 100 is the sample space, right? Then the 85 is the mark that you obtained. I don't know what is that I wrote, the mark what, but I wanted to write mark obtained. So the mark obtained now is 85 over 100. Then that's equal what? Probability. So that is probability. I hope now I try to explain what the probability is. So that's very, very important. It's very important. Probability is equal to favorable outcome over the sample space, the total number. All right. We have the general formula for probability. Remember now you have a clue of what probability is. We have this is the general formula: P of A or B equal to P of A plus P of B minus P of A and B. So that P is the probability, right, of A or B equals probability of A plus B minus probability of A and B. So if they would write something like P union B, so the same thing as P of A or B. Or if they don't want to say P of A and B, they can actually write something like this. It's one and the same thing. I hope that makes sense. And the and between A and B tells us about what? The intersection. It tells us about the intersection. Let me just fix my spelling. The intersection, yes. it means that the event A and event B, they have something in common. They intersect, in other words. I hope that makes sense, but you're going to understand everything as we are about to explain the events, right? I hope you're still following. If you do, please do not forget to like the video. So we have events. We talk about events in probability, and not the gigs but events. You will see what I'm talking about. We have mutually inclusive events. We have mutually inclusive events. These are different types of events we're going to talk about. We have mutually exclusive events. Then we have the exhaustive events. Don't just say these events are exhausted. No, you will see when we explain them. So complementary events are one of the events that we're going to actually explain or talk about. Then lastly, we have independent events. We do not have dependent events. Don't mention those. These are the events that we're going to talk about. So I'm going to erase all of them, then we talk about one event, right? Then we help each other to understand this easy topic. This is actually paper one topic. So you must know how to differentiate these events. You must know that when they talk about mutually inclusive and all of these events, what are they actually saying when they mention something like mutually exclusive events or inclusive, exhaustive, complementary, or independent events. So let me just erase all of them, then we talk about the first one. Or let me just restore all of the events, then we talk about the first two, the mutually inclusive events and the mutually exclusive events. So another thing here that you must understand is that we see the term inclusive and exclusive, right? So take inclusive as if it is include, or included. Inclusive comes from the word include, right? So take this one as excluded or exclude, meaning that the events here, let me just show you the events. So this is a Venn diagram, and the second Venn diagram is like this. So this is event A, event B, event A, and event B. Now you can see these events right here. Let me just use a red color. These events right here. You can see that they have something in common, meaning they are included, meaning they are inclusive. What does that mean? It means that they have something known as intersection. They have something in common. I hope that makes sense. So these are mutually inclusive events. Why? Because they are inclusive, meaning they have intersection part, the green part that you see there. Now let's talk about these ones. You can see that this is event A and this is event B. They have nothing in common, meaning that they are excluded, they are separated. They do not have intersection, meaning that their intersection is 0. I hope that makes sense. So mutually inclusive events and mutually exclusive events are like this. So the intersection of this event is 0 because they are not included, right? They are excluded. So the intersection of these events on this Venn diagram is not equal to 0. Therefore, P of A and B is equal to 0 here. Why? Because the events are not sharing anything in common, do not have anything in common, or something in common. Yes. I hope it makes sense. Then we have exhaustive events. Don't say these events are exhausted, they are tired. No. But when you talk about exhaustive events, you're talking about events whereby the P of A or B, the union, is equal to 1. So that's very important. When they say exhaustive events, you must know that where there's P of A or B, you substitute 1. When they say mutually exclusive events, where there's P of A and B, you substitute 0. But inclusive Intersection cannot be 0. I hope it makes sense. Then we have events that are independent. We do not have dependent events. We only have events that are independent. So what are we actually saying when we say that the events are independent? It means that the P of A and B, the intersection, must be equal to the product of A and B, right? Meaning that the intersection, if it is equal to the product of, if it is equal to the probability of A multiplied by the probability of B, it means that those events are independent. So if you have your intersection as 0.5, then when you multiply probability of A and probability of B, they give you 0.5. It means that those events are independent. Why? Because the intersection is equal to the product of probability of A and probability of B. The product, when I say product, is what it is times. So we have what? Complementary events. Complementary events. I hope you are writing. So complementary events are actually events that are formed by mutually exclusive and exhaustive events, but we're going to talk about that. Now we have something known as P naught A. P naught A, you must know that it is equal to 1 minus P of A, or P of let me just fix this here. P of B, P naught B equal to 1 minus P of B. So this is very important. Or they can actually write it like this. If they don't write P naught A, they will just write something like this: P prime of A, P prime of B. It's one the same thing as P naught A or P naught B. It's one the same thing. I hope it makes sense. So these are complementary events. I'm going to explain it after this thing. That complementary events, how are they formed? That's very, very important for you guys to know. All right. Now let me show you an example of how they ask these questions, including P naught A or P naught B. All right. So let's say we are given P naught A as 0.45. Then they want us to determine P of A. So what we're going to write here, we know that P naught A, is one the same thing as P prime of A equal to 1 minus P of A. They want us to determine P of A. We do have P naught A as 0.45 equals 1 minus P of A. Then we transpose 1 to the left, then it's going to be 0.45 minus 1 equals negative P of A, right? Therefore, you punch your calculator. Don't try to make yourself a staring. Use a calculator. Even if they say 0 plus 0. If you are not sure, use a calculator. So it's going to be negative 5.5 equals negative P of A. Then divide both sides by negative 1. After dividing by negative 1, you'll have your answer as positive. I don't know where did I get that 5.5, because it's 0.55. Please forgive me on that. My apologies. But I hope you understood this. That's very, very important. This is how you solve these events, or something having not A or not B. Okay, so now I think I'll actually try to explain the complementary events, how they form the formation of these events, because that's very, very important. When they talk about complementary events, there are two things that you must know, or there are two events that are actually in place there for the formation of complementary events. Okay, please do not forget to subscribe to the channel and hit on the notification bell so that you can be notified when I upload new videos. And another thing that's left is for you to like the video. If you can do that, I'm telling you, you're going to understand the entire topic. All right, let's just continue. Let me try to explain the complementary events. Now let's say we have P of A and B equals 0, and having P of A or B, the union, being equals or being 1. So these are exhaustive events, right? When probability of A or B equals 1, it means that the events of A and B are exhaustive. But when the intersection is equal to 0, it means that the events A and B are mutually exclusive. I hope that makes sense. So what you must know, that if the events are mutually exclusive, or if the intersection equals 0 and probability of A or B equals 0, the meaning of that is that they form what is known as complementary events. I hope that makes sense. So when they say complementary events, it means that when they say the events are complementary, it means that, so they will actually tell you in a statement that the events are complementary. It means that the intersection is 0 and the P of A or B equals 1. That's very, very important. Now, let's say we have P of A or B. This is the general formula for probability minus the intersection of A and B, right? So when they say the events are complementary, it means that the intersection here is 0 and the OR is equals 1, and the probability of A or B equals 1. I hope it makes a lot of sense. This is very important. It's something that you must know. Make sure that you know this. Very, very important. And I forgot to tell you something important, guys, that we are actually having our classes in First Loras. If you're around First Loras, we do have our classes on weekends, Saturday and Sunday, for grade 10 to 12, and during the week, Monday to Friday, we are with those that are upgrading their results. Then we also have online classes for grade 12s, preparing them for the preliminary exams or prelims, Monday to Thursday. So here they want us to determine P of B. Now for any two events A and B, it is given that P of A equals 0.35 and P of A or B equals 0.61. And determine P of B if A and B are mutually exclusive. So when they talk about A and B being mutually exclusive, the meaning of that is that the probability of A and B is 0, right? So we're going to use the general formula P of A or B equal to P of A plus P of B minus P of A and B. The P of A and B must be 0. Why? Because they're saying that A and B are mutually exclusive, right? We are given the value of P of A or B as 0.61 equal to P of A, we are given 0.35 plus the one that we are actually determining, which is P of B, plus P of B minus 0. Why? Because they said mutually exclusive. So P of A and B will be 0. Therefore, 0.61 minus 0.35. We're going to get the answer of P of B being 0.26. So, sorry, it's supposed to be 0. So, it's 0.26 as the answer of P of B. There are no SI units here. I hope it makes sense. So it's very important for you to know when they talk about the different types of events, what is the meaning of each event they're talking, what is the meaning of the event they're actually mentioning. So since they say that event A and B are mutually exclusive, what is the meaning of that is that the intersection part is 0. So they want us to determine P of B if A and B are independent. So now when they say A and B are independent, it's very important for us to know that the meaning of them saying that A and B are independent means that when we multiply the probability of A and the probability of B, they must give us what? The answer must be equal to the intersection. Therefore, let's actually try to use this formula. P of B minus P of A and B. Remember, this is what? This is the intersection. Okay, now let's see. We are given the value of P of A or B as, let me just go up there. So this is our general formula. So we are given P of A or B as 0.61 and P of A is 0.35 plus P of B, the one that we are determining, minus, we know that this is equal to P of A and B is equal to the probability or the product of probability of A and B, meaning where there's P of A and B, we're going to replace it with what? With P of A times P of B, because they're saying that they are independent. I hope that makes sense. Times P of B. Alright, now let's actually substitute the value of P of A. Therefore, what we're going to have right here is going to be 0.61 minus 0.35. Then after that, we substitute P of A. I hope it makes sense. And if you don't understand it, make sure that you rewind the video. So it's going to be 0.61, okay, 0.35 before we can actually calculate them, plus P of B. Now what's the value of P of A? We are given 0.35, right? Multiply by P of B. Therefore, 0.61 minus 0.35, use your calculator, and I'm going to tell my students that do not make yourself a staring. Use a calculator so that you can get accurate answers. So it's going to be 0.26. Then it's equal to P of B minus 0.35 P of B. Then this thing here, it's like we are having, it's like something x minus 2x. So the coefficient of P of B here, it's 1. Therefore 1 minus 0.35 is going to give us 0.65. I hope it makes sense. Therefore 0.26 equal to negative, not negative, it's 0.65 P of B. Then we solve P of B by dividing both sides by 0.65 to make the probability of B the subject of the formula, as it is what we are required to calculate. Therefore P of B equals 0.26 divided by 0.65 is going to give us 0.4. So 0.4 is our answer. So I hope you understand it. So now I'll try to prove it. So P of B multiplied by P of A, if the events are independent, they must be equal to the intersection of A and B. So do we have the value of probability of B? It's 0.4. Probability of A is 0.35. So they are equal to the intersection. So let me just try to use my calculator right here. 0.4 times 0.35 is going to give us this calculator is giving me problem, 0.14. So meaning that the probability of A and B, the intersection, is 0.14. Then after this, I'm going to use what? The general formula to determine P of A and B to see if it's going to give us 0.14, because this answer we're getting it now by multiplying the probability of A and probability of B, and it gave us 0.14. Then this is the answer of P of B as 0.4. Therefore, right now I'm going to use what? The general formula to determine the probability of A and B, the intersection of A and B, to check if it's going to give us 0.14. Then if it gives us 0.14, it means that our answer 0.4 as P of B is accurate. Therefore, the general rule or general formula equal to P of A or B equal to P of A plus P of B, or the probability of A or B equals the sum of A and B and the difference of the intersection. Then we do have probability of A or B as 0.61 equal to, okay, let me double check, is 0.61. Then probability of A is 0.35, probability of B is 0.4 minus probability of A and B. We just want to prove if our answer is correct. So 0.61 minus 0.35 minus 0.4 and make the intersection of A and B, or the probability of A and B, to be the subject of the formula. So negative 0.14 equals negative probability of A and B. We divide both sides by negative, then the answer of the intersection is 0.14. It means that our answer of P of B as 0.4 is correct. I hope it makes sense. So this is how you determine what the probability of A if A and B are independent. Here's another example. Let's try to do it. Given P of A and we're given all these values where A and B are two different events, then what they say that are the events A and B mutually exclusive. Justify your answer with appropriate calculations and or a diagram. Okay, so I'm going to use calculations, but it's possible for you to use what diagrams. You will ask your teacher, he will show you or she will show you how to do so. So probability of A or B equals probability of A plus probability of B minus probability of A and B. That's the intersection. Then what you're going to do, you're going to substitute, right? You're going to do the substitution. P of A, we do have, P of A or B must be 0.8. So 0.8 equal to P of A. P of A is 0.6 plus P of B, we do have 0.3 minus P of A and B. Then you subtract 0.6, 0.3 from 0.8. Therefore 0.8 minus 0.6 minus 0.3 is going to give us negative 0.1. Let me just fix my 1 here. Negative 0.1 equal to negative P of A and B. Divide both sides by negative 1. Therefore 0.1 equals the probability of A and B. And we can see now that the question was asking us if the events are mutually exclusive. Therefore they are not mutually exclusive. Why? Because mutually exclusive events, the intersection must be 0, but this one is not 0. Therefore our answer is no. Why? Because probability of A and B is not equal to 0. So this is our answer. This is 4 marks. You don't just say yes or no. Justify it using appropriate calculations or a diagram, a Venn diagram. But after this, we're going to discuss Venn diagrams. Okay, here's another question. So you'll try to do these questions on your own to see if you understood what we were doing so far. Then we'll be continuing to do to show you how to represent information in a Venn diagram. So these are known as Venn diagrams. If I'm going to explain each and every Venn diagram drawn on your screen there, as you can see. So this is event A. So this circle here is known as an event. So since we have one event, it means it's an event A. That's why we don't have B. Okay. So everything that we are actually, okay, here we're having A, B, event A, event B, event A, event B, and event C. Okay. Now, everything that we are having outside here, for example, let's say we are having learners who are participating in a survey, then the number that will be written outside here will be a number of the learners who are not participating in a survey or in any function or sport. I hope that makes sense. The number that will be written outside here, the event, because there will be numbers that will be written inside the event, are those that are participating in a survey or whatever it is, but the ones that will be outside where I actually marked, they won't be participating. So these are event A and B. They are mutually exclusive, meaning that the intersection is 0. So P of A and B, that's intersection. They don't have an intersection, right? But these ones here, this is an intersection, meaning that they have something in common. They are known as mutually inclusive events. Their intersection cannot be 0. I hope that makes sense. So here, these are intersections, meaning if we have 3 events, we have more than one intersection. So this is the intersection of all the events A, B, and C. Then this one here, it is the intersection of A and B alone. And the one that we are having right here is the intersection of A and C, as you can see. And let me just use another color. Let me try to see if I have pink color here. Your favorite color, or your sister's favorite color, or your dad's. So this is the intersection of B and C. So it's very important for you to know how to represent information in a box, in a Venn diagram, or to know how to interpret a Venn diagram. I nearly said box and whisker. My mind is full of mathematics. I'm kidding. This mind is full of the good news about the Lord Jesus Christ. Okay. By the way, I'm born again. I'm a child of God. Yeah, I'm born again. Jesus Christ is my Lord. Now, he's the one who's teaching me mathematics, giving me the knowledge and understanding. All right, so let's actually start. All right, the 10 learners that are asked about the sports they play. So, I don't know if you are playing sport, but we are not there. 10 learners are asked about the sports they play. So the number of learners here, the total number is 10. 3 play both soccer and cricket. Okay. 2 play cricket only. 4 play rugby. Then they say represent the information in a, sorry, it's not box and whisker, Venn diagram. Okay. Now here we must actually discover how many events are we supposed to show in our diagram. 2 of them. Why? Because we are talking about soccer and cricket, right? That's very important. So these learners that are playing sports, I'm not sure about you. Yeah, some other learners are playing sports. 3 play both soccer and cricket. They play both, meaning that they have something in common, right? So let's try to represent our information in a Venn diagram. All right. Let me just draw the events inside this rectangle. or a simple space. This is event A, then this is event B, but now we won't actually call them event A and B, but it will be event S and event C. S for cricket, S for soccer, C for cricket. Soccer and cricket. Now they have something they have in common, that three play both, meaning the 3 will be the intersection of both the sports, and the number of simple space there is 10. Make sure that you write on top of your rectangle or the simple space the total number. So here it is what the intersection, where soccer and cricket having something in common, which is 3. So they intersect here. 3 play both soccer and cricket. Then 3 play cricket only. This is very important. The term only is very important, but I'll explain it shortly. So you'll actually take that 2 and write it as it is on the bigger space of cricket. So it's 2. Then they're saying you will see the difference between these two. 4 play soccer. There's no only. Since there's no only, you're going to say 4 minus the intersection. You write the answer, which is 1. Right? But if it was written 4 play soccer only, we're going to write 4 as it is on the soccer event. I hope it makes sense. Now, let me try to restore my information here. Okay. So, everything inside the Venn diagram must give us what? 10. But if it doesn't give us 10, meaning that the number of the learners who are actually not playing any sport, you write it outside the event. So 10 minus the 6 we are having, it will give us 4. Then this 4, it tells us that this number of learners are not playing sports just like you, right? So this is how you represent the Venn diagram. Your information in a Venn diagram. You must understand only. If it's only, you don't subtract it from the intersection. A survey is done on the technological devices that teenagers own. 150 teenagers were surveyed and the following results were obtained: 125 on cell phones, 47 on tablets, and 58 on laptops, 40 on cell phones and laptops, 50 on cell phones and laptops, 35 on tablets and laptops, 30 on cell phones, laptop, and tablets. So they want us to represent the information in or on a Venn diagram. So the first thing that you must do here is that you need to discover how many technological devices are they talking about, so that we can be able to show them the events. So they're talking about 3 technological devices, meaning that we're going to actually have 3 events. Let me try to draw the circles or the events. Let's try to enlarge the circle and position it right here. Then the second one, so this is very important. Before you can show the events, check how many events or how many technological devices or sports are they actually talking about. So here they're talking about 3 technological devices, meaning we must have 3 events. So this is the third one. We cannot have these ones being excluded, as if it's like a 3-plate stove. They are always included. Okay, let me just put it right here. Okay, so this is for cell phone, tablet, and L for laptops. Then the number of sample space here, you write it on top here. Remember, we have 150. Let me just confirm it. We have 150 teenagers, right? Therefore, you write it here, number of sample space equals 150. Okay, now the first thing that you must do is that you must actually start with the intersection or the intersections where the events are actually having something in common. They're saying that 30 own cell phones, laptops, and tablets. So this is the intersection of all the events or of all the technological devices. Then 35 own tablets and laptops. Therefore, you're going to say 35 minus 30. Then you put the 5 on the intersection of what? Of tablets and laptops. But if it was only, you are not going to subtract. Remember from the previous video. Therefore, 50 own cell phones and laptops. That's what? 20 right here, because that's the intersection of cell phones and laptops. Then 40 on cell phones and laptops. Therefore, 40 minus 30, you're going to have 10 right here. But if there was only, you are not going to subtract it. Remember, from the intersection. Therefore, 125 on cell phones, this is what you're going to do. You're going to say 125 minus, you're going to say 125 minus everything here, as you can see the red line. Therefore, it will be 125 minus 20 minus 30 and minus 10. So the answer is going to be 65. Right? 57 own tablets. So you're going to subtract the entire thing here by that 47. So it will be 40. It's going to be 2. Yes. But if it was only, you're not going to subtract anything. Then I hope you understand that part. 58 on tablets. It will be 58 minus 55. 58 minus, 58, yes, minus 55 is going to be 3. 50 minus 20 minus 30 minus 5 is 3. Then remember here, it's not 6, it's 65. I think it was erased as I was busy with this pen that I'm using here. So let's just restore back the 5. So it was 5 here, not 65. This pen of mine is glitching, but here it will be 2, remember? And oh my goodness, this pen of mine is glitching. I'm trying to write a 5. Let me just switch it off and switch it on. Please bear with me, good people. Alright. Yes. And if you actually add everything that's inside the event, it must give you 150. So if it doesn't give you 150, you write the remaining outside the events. That will be the number that actually the teenagers who are not having any technological device or who are not owning any technological device. So it will be 150 minus the number that we are having when we add the numbers in the event. So it's 150 minus what? 135. Then we're going to have 15. That 15 is the number of the learners who or teenagers that are not actually owning any technological device. Right? But owning a technological device doesn't mean that you're going to pass. Yeah, I was just saying that. Alright, I hope you understood this. Please like the video. So we are given this information here, the available modes of transport, buses, minibus, taxis, and trains. So meaning that we are having 3 events. That's very, very important, and they are all inclusive, right? We do not have 3 events that are excluded or exclusive. So there are 100 learners from Maths and Science series tutoring. Okay, so this 100 here, it tells us about what? The sample space, the total number of the learners, right? Therefore, we are listed with our data right now. Then after that, we'll actually represent our information event diagram. So here 29 use bus, 62 minibus, taxis, 40 use trains, and 12 use 22 use buses and trains, meaning this is the intersection between two events, buses and trains, right? And here we have 17 that are using minibus, taxis, and trains. So is what is the intersection between two events, but we want the intersection of all the events. 13 don't use public transport, meaning it is outside the events, right? Then they say that because look at this, these are our Venn diagrams. Before we can actually have these ones, we must actually first start with what, with the intersection of the intersections. I hope it makes sense. So we didn't find it in our information here. Let's just continue reading the statement. Now they say, let the number of learners who use all three modes of transport be X, meaning that this X will be the intersection of intersections. I hope it makes sense. Then they want us to represent the information in a Venn diagram. Okay, so here are our three events here. Here are our three events. So they said that the intersection of all the three events is X. I hope that makes sense. Therefore, we're going to take that X and put it right here. We just change the color and put it right here. And let's actually give our events their names. We have event minibus. We have 13 outside here. Those ones that are actually not using public transport. They're just using 5+5 to go home and to come to school or to go to school. Okay. So we have minibus taxis, we have buses, and we have trains. All right. Now let's continue. 13 don't use public transports. That's the 13 outside. Then 17 use minibus, taxis, and trains, meaning that it is the intersection between minibus, taxis, and trains right here. Therefore, it will be that 17 minus the intersection. I hope you remember that. But if it was only, you are going to write it as it is. I hope it makes sense. But there's that end. So the end tells us about what? The intersection. 22 use buses and trains. That's the intersection between buses and trains. Where are buses and trains? Right here. So it will be 22 minus the intersection. I hope it makes sense. Then 12 use buses and minibus taxis. That's the intersection between these two events. Where is that intersection? Is right here above the intersection. So it will be 12 minus X. All right, we are done with the intersections right now. Let me just show you all the intersections we're having from the intersection of the intersections to 12. Those are the intersections. So we are done with them, meaning now we're going to actually fill up those empty spaces of the events. They're exactly one event. Okay, 29 use buses and 29 use buses, meaning that we're going to take this 29 and subtract everything here so that we can get the answer there, right? So it will be 29. Let me just write it down here. It will be 29 minus into 12 minus X minus X, the intersection of the intersections, minus open bracket 22 minus X. Then let's just distribute the negative inside the brackets to get rid of the brackets. I hope you see what I'm doing here is just the FOIL method. Then minus X, then distribute the negative again, minus 22 and plus X. I hope it makes sense. And please don't forget to subscribe to the channel and to like the video and to share it and to comment. So these ones are going to cancel out because they are the same but of different signs. Therefore, we are left with what? With the X here. So we have an X, then you actually use your calculator. So it will be -5 plus X, or X minus 5 is one and the same thing. Just write it right here. I hope it makes sense. Then 62 use minibus taxis. So I'm going to say 62 minus everything there to get the answer on the empty space. Let me just show you. So it's going to be that 62 minus everything here to get the answer right here. Therefore it's going to be 62, then you minus everything as I showed you, minus 17 plus x. I hope you understand this, minus the intersection, minus 12 plus x. Right, let me try to fix the 12 right here. So yes, 12 plus x. Then these two are going to cancel out. As you can see, this is mathematics. Therefore, use your calculator to write 62 minus 17 minus 12. That's 33 plus x. Therefore, write it right here, 33 plus x. We're only left with that empty space on the T event or train event. Then 40 use trains, not buses. 40 use trains. 40 use trains. So I'm going to say 40 minus everything here equals the answer right here on the empty space, right? So it will be 40 minus 17 plus x distributed in negative minus the intersection of the intersections minus 22 plus x. Then these two, they cancel out right here. Then 40 minus 17 minus 22. Just use your calculator. Don't try to make yourself a staring. So it's x plus 1 or 1 plus x. I write it over here. So this is what? This is the Venn diagram. I represented the information in the Venn diagram. This is what you do. You remember the time we're actually representing our information in a Venn diagram using numbers. Doing the same thing even when you have unknown variables. You do the same thing, or same thing applies. I hope it makes sense. But sometimes you can be asked to determine the value of x here. I will actually show you that shortly, but this is very, very important, guys. So I think what you must know here and what you must do again is for you to like the video. And another thing, we're having our classes in Fossilores. If you are from grade 10 to grade 12, or even if you are actually upgrading your results, we do have contact classes whereby you can actually come to our venue and we'll help you. So for more information, just actually get our number here. We'll actually put it at the end of the video for more information. Okay, now let's say they want you to determine the value of x, or they want you to solve for x. What you must do is that you are going to add everything here, and outside the events, you equate whatever number or whatever numbers that you're going to get to the sample space right here. I hope it makes sense. You add everything inside the Venn diagrams, and the numbers that are outside, or a number that is outside the Venn diagram, you equate them to the sample space, so it's a total number, which is 100, right? So I'm going to add everything here. 33 plus x plus 17 plus x plus 1. You add everything. Minus 5 plus x. Then plus 17 minus x plus plus 22 minus x plus 12 minus x plus x equal to 100. So you add everything inside the events and outside, then you equate whatever to the sample space. We know that our sample space is 100, so these ones are going to cancel out, and these two are going to cancel out. What else? All right, So you add the numbers. So these numbers, you add them using your calculator and you equate to 100, then you solve for x. So 33 plus 1 minus 5 plus 17 plus 22 plus 12. You equate them to 100. Okay, I'm just trying to use my calculator right here. It is giving me problems, but we're going there. I'm trying to punch this. As I'm actually punching my calculator right here, please go to the comment section if you understand this. Just write that we understand, Mr. Alton. Okay, so it's 80 equals 100. So you solve for x here. X equals what? Equals 20. X equals 20. Wait, we forgot to add the 13 before equating to the simple space. Okay, let me try to fix that. So you must add the 13 here, right? We said that we add everything inside the events and outside the events. Then that's when we equate to 100. So we're going to add this 13. I forgot about it. I forgot to add it. So it's going to be x plus 93 equal to 100. Then x equals 7. So this is how you do this. I hope it makes sense. You add everything inside the events and outside, then you equate it to the sample space. I hope it makes sense now. This is very, very important, guys. Very, very important. And please make sure that you share this video to your friends so that they can actually understand this thing as you are understanding it. All right. On weekends, we are having classes for grade 10 to grade 12, physical sciences, mathematics, life sciences, accounting, and mathematical literacy. Okay, let's say we have event A and event B, event A and event B. Let's just explain this, then we continue, because I don't think I actually explain this in more details. So here, let's say we are talking about the intersection of the events, and the union of the events. So here, let's say we have the probability. Remember, this is not just a number, the probability, meaning that you added whatever that you added, then you divide by the total number. This is the probability of A or B. So what you must actually understand here, or what you must know, is that this thing can be written as A and that thing there B. P of A union B. So you must actually be careful on that. Make sure that you know it, be aware. Okay, so the intersection here, it is this part, the probability of A and B. It is this blue part I'm actually highlighting here. I'm not sure if that color is blue or yellow. I don't know colors. So it is the common thing that A and B are actually having or sharing. I hope it makes sense. Now, but when we actually talk about probability of A and B, you just actually take that, then you divide it by the sample space. But P of A or B, you actually add where you see the ticks, then you divide it by the sample space, unless if the numbers written inside the events are the probabilities. I hope it makes sense. Please rewind that to understand what I said there. So it's very, very important. Very, very important. All right, so if the numbers that are written inside the events are probabilities, there's no need for you to actually do whatever that you're going to do here and divide them by the sample space. You just take those numbers if they are probabilities, right? I will explain it again. So let's say you are given the probabilities. They want you to determine the probability of A and B. So it's right here. Then the probability of A or B, what you must know is that you must actually add whatever that is inside the bracket, as I'm going to actually do the ticks. I hope it makes sense. Then the probability of not A, this is where you find the probability of not A. I hope it makes sense. Now the probability of A and not B, you actually take the number that is right here. Then if those numbers that are inside the events are not probabilities, you add them, then you divide them by the sample space. But if they are not actually they are probabilities, there's no need for you to actually divide them by the sample space, because they are already what? The probabilities. I hope that makes sense. Very, very important. You must know these guys by heart. Very, very important. And P not A and not B, it is the ones that are not actually participating, they're outside. All right, so you can be given something or things like this, events like this. So when they talk about at most two of the three devices, now let's say they don't want probabilities, you just add everything right here. You add everything where you see the ticks, then you give them that number. For example, let's say how many learners are actually using the three modes, at most two of the three devices. You add those numbers. But if they want probability, you actually add the numbers, then you divide all of these by the sample space. I hope that makes sense. Now if they want how many learners at least, or how many at least two of the three devices are used by, then as you just add these, and you don't divide it by what? By the sample space. But if they want probability, you add, then you divide by the sample space. I hope that makes sense. Very, very important, guys. Okay, now they want how many numbers of the learners who are not actually having the sample space. It's one that is, those that are not actually using none of the three devices. You just take that number that is outside. But if they want probability, you take that number that is outside, you divide it by the sample space. At least one of the three, you add these, then that would be the answer. But if it is probability, the one probability, you actually add them, then you divide them by the sample space, then the answer becomes what? The probability. Same thing applies right here. Exactly two of the three devices. If it is not probability, you'd add these numbers as I'm taking right here. But if it is probability, they want you to determine the probability, you add them, then you divide them by the sample space. Very, very important. Now, exactly one of the three devices, you actually add these, then you divide them by the sample space. If it is what? Probability. But if they want the number saying how many learners are using exactly one of the three devices, you don't remember, they're not asking probability, meaning it's very important for you to check first if they are asking you to determine the probability or just the number of learners. If it is the number of learners, you add, you don't divide by what? By the sample space. But if they want probability, you add where they are ticks, then you divide by the sample space. Then that becomes what? Probability. Why? Because probability is what? The favorable outcome divided by the sample space. But if they just want the number of learners, you just give them the favorable outcome without dividing by the sample space. No, I tried to explain this. I tried. So please subscribe. Thank you, guys.